Well, let's test another series for convergence using our ratio test. This time we're going to look at the sum from 1 to infinity of n to the n over n factorial. So both of these functions are growing very fast. They're both heading off to infinity as n goes to infinity, and it's kind of hard to tell which one's going to win the race. So we take the limit as n goes to infinity of the absolute value of the n plus 1th term over the nth term. And that's the limit as n goes to infinity of n plus 1 to the n plus 1 over n plus 1 factorial divided by n to the n over n factorial. And now rearranging this a little bit, we get n plus 1 to the n plus 1 is n plus 1 times n plus 1 to the n, and n plus 1 factorial is n plus 1 times n factorial. And of course, inverting that fraction in the denominator, we multiply that by n factorial over n to the n. Now you can see the n factorials cancel, and the n plus 1's cancel. So we're looking at the limit as n goes to infinity of n plus 1 to the n over n to the n, are n plus 1 over n to the n. And this is the limit as n goes to infinity of 1 plus 1 over n to the n. And you might know already from part of our lectures that this is a very special limit and it's equal to e, but if you don't remember that, you can always figure it out using L'Hopital's rule. So replacing the n by an x, this is the limit as x goes to infinity of 1 plus 1 over x to the x. And this is an indeterminate form. It's the limit as x goes to infinity of e to the x times the natural log of 1 plus 1 over x. And this is e to the limit as x goes to infinity of x times the natural log of 1 plus 1 over x. And looking at that limit in isolation, we see that that's the limit as x goes to infinity of the natural log of 1 plus 1 over x over 1 over x. And now applying L'Hopital's rule to this indeterminate form, we get that that's equal to the limit of the quotient of the derivatives, which is the limit of minus 1 over x squared over 1 plus 1 over x divided by minus 1 over x squared. And the minus 1 over x squares cancel, and it's the limit as x goes to infinity of 1 over 1 plus 1 over x, and that's equal to 1. Our original limit is now equal to e to the 1, and this is the limit as n goes to infinity of the absolute value of the quotient of an plus 1 over an. So that limit is equal to e, which is greater than 1, and therefore by our ratio test, the series diverges. The sum from 1 to infinity of n to the n over n factorial is divergent.